Okay, so this is one question on equimomental system. So this question also very important. This to give in your exam to find the equimomental system. So the question is find the equimomental system of particles for a uniform rod AB of mass m. Okay, so you have to find the equimomental system of particles for a uniform rod AB of mass m. So the same question can be also asked as show that the uniform rod of mass m is equimomental to the three particles situated once at each end of the rod and one at its middle point. The mass of the particles being m by 6, m by 6 and 2m by 3 to m by 3 respectively. So this is your question. Means here we have to find the moment of find the equimomental system. Means we'll try to find another body which have the same mass, same centroid, and the same moment of inertia and principal axis above the centroid. So we are going to find two bodies here. So one body is already given. So I will consider another body. Okay. So this is your answer for this. So we are considering another body. So we'll try to find what will be that body, okay, which is equimomental to the rod. So we are finding one body which will having the same mass, same centroid, and same principal axis and the principal moment of inertia about the centroid. So here I'll take one rod, okay. I'll take a rod here. This is a rod, okay. So I'll use the same diagram what is given here. So here I'm taking this I'll take as a b, and the mass I'll put is here small mass, that is m, and I'll take here a small mass, that is I'm taking here the mass to be small m. And at the centroid, this is the centroid of the rod, and at the centroid of the rod I'll put another mass. So the total mass should be m, because we have taken the mass of the rod is capital M. So the total mass should be m. So what mass I should put here? The mass what I'll put here is nothing but m minus 2m. Okay. So if we add all the mass, we are getting m. So we are considering another system consists of three particles, okay, which are put at the corner of the rod. Two particles of mass m are put at the corner of the rod, and one is put at the centroid of the rod. So this I am taking as G. So here we have this. We'll try to find what is this line I'm taking as GL. So I'll try to find what will be the moment of inertia about this L. So what is the moment of inertia of a rod? Okay, what is the moment of inertia of a rod passing through the centroid? We have done already in the beginning of the class. What we have started, we have find already the moment of inertia of a rod about the center as well as at the corner. So you have to look this. Now you have to check go back to your notes and you check that the moment of inertia about the center was what. So we have proved already that the moment of inertia about the center was nothing but it is 1 by 3 ma square, where AB equal to 2A is the length of the rod. Okay, so we have proved this one. So I'm assuming this that we know. So moment of inertia of the rod about GL is MA square by 3. Okay, now I'll try to find the moment of inertia of these particles. Okay, moment of inertia of this particle about GL. So what will be the moment of inertia of okay, moment of inertia about GL for these particles. So what will be the moment of inertia for this particle about GL? It is mass into perpendicular distance. So what is the perpendicular distance from here to here? This is nothing but A, because the total length is what? From here to here, the length is nothing but it is given as 2A. So that's why this length will be A, and this length also will be A. So what will be the moment of inertia is moment of inertia of one particle is nothing but mass into square of the perpendicular distance from the axis of rotation. So this distance, perpendicular distance is a. So we'll have here ma square plus, for this body, now above this line, so m minus 2m. What is the perpendicular distance? So there is no distance, so the distance is 0. So 0 square plus, what will be the moment of inertia of this body about this line? GL, it is nothing but mass into perpendicular distance. So the perpendicular distance is a, so a square. So we get here ma square. Okay, so what we'll have here? So we have here what? This will be 0. This will contribute you ma square, and this also ma square. So we get here 2ma square. So we get here 2ma square. That is the moment of inertia of this particle about the line GL. Now, in the same way, we have already found the moment of inertia of the rod about GL. Now, since they have given you that the two systems are equimomental, they have given you, okay, they have already given you that the two systems are equimomental, they should have the same moment of inertia about the line GL. So if you see here, they should have the same moment of inertia about the line GL. So what was the moment of inertia of the rod? Since the system are equimomental, okay? Since the systems are equimomental, okay? Since the system is equimomental, we'll have what? Moment of inertia of the rod about GL, we got here, it is what? 1 by 3 ma square. And here, how much we got? Moment of inertia of the particle about GL, we got here, it is 2 ma square. Now, here a square and a square will be cancelled. We have this 1 by 3 m is equal to 2m. So what is your small m? Small m is nothing but m by 6. So what mass you will put here? The mass which we will put here is nothing but m by 6. Okay, and here also will be m by 6. Then what mass will you put here? So we can calculate this. If we calculate this one, m minus 2m. So we get here m is m minus 2m. M is m by 6. So the LCM will be this and this cancel, we get 3. So we get 3m minus m divided by 3. So this we get 2m by 3. So the moment of the mass which we are putting at the centroid of the rod is nothing but it is 2m by 3. So if we take 3 particles, then the 3 particles will be equimomental to the rod only if the mass of the particle which is placed at the corner will be m by 6, and other corner also will be m by 6, as well as the mass which will be placed at the centroid of the rod should be 2 by 3m. So this shows that the two systems are equimomental. So we have proof, and we can also, because this is we have proof already that the mass what we are putting at the at the ends of the rod is m by 6, and at the centroid it's nothing but it is 2m by 3. Thank you.